we're currently running at 7.9 kilowatts. We're showing 3750 watts, 31.2 amps. We're showing 4100 watts at 35.8 amps.
Okay, for this project, we're actually going to be building a load tester that'll allow us to verify the load on generators capable of 240 volts up to 50 amps. And the purpose for it is to determine load balance one leg to the other leg. The generator produces 220 volt legs, and we need to know how many amps, watts, and voltage is available at each leg and be able to determine how far off the balance is, because we've had a problematic generator and we're working on getting it resolved. So what we have here, we'll start here, and this is big stuff. This is actually a 6-gauge 4-conductor wire capable of 600 volts, but we only need it for 240. But it is capable. It comes with two lines, 220 volt lines, a neutral and a ground. You see there, the green's the ground, the white's the neutral, then you got the red and black, and them are both the lines. That is going to be capable of a full 50 amps. We're only running it into 30 amp plugs at this time. That'll work to sustain our load, but this will give me the ability to upgrade the plugs to a 50 amp at a later date. Now here we have our meter. This meter is capable of reading amps, watts, volts, power factor, kilowatt hours. It's loaded down. It can do a lot of stuff. But the problem with this, it has 2 CTs, which are known as circuit transformers. Now with these circuit transformers, it's got 2 of these, one external, one built in. Now with these circuit transformers, you run one of the hot leads, which will either be the black or the red, through it. And if you run it through it like so, and then you run power, this will measure how many watts is being drawn through this wire, how many amps is being drawn through this wire. It'll pretty much give us the big picture, and it'll help monitor the kilowatt hours. The problem with this meter, I like the meter, I like the setup, but this is set up with only 2 leads, which will basically be a line and the common, which will be the white wire. It is not capable. Now it can, with the channel button here and the channel LEDs, it's got this circuit transformer there, and then it has another one that's internal built in here, and it goes completely through the unit. But the problem is, that's not going to give us the voltage on the other side. Whatever these 2 lines are going to is only going to give us the voltage on that side, but not the other side. So what we are going to do to get around that, so we can get the solid readings from both sides, we are going to incorporate a machine switch right here into our system. Now this switch is going to have a signal wire from both lines coming to this switch, and then from this switch, both signal wires are going to be ran to the hot lead on the meter. Then we can switch back and forth from line 1 to line 2. Or if we don't want to use the meter while it's plugged in, we could just flip it to 0 and then it's completely off. And that will let us check the voltage and the voltage and a couple other things and the hertz on the other side. And that's the other thing it measures. It measures frequency. So we have our 14-30P, which we will be putting on the end of our cord, but because this is designed for only 30 amp and we went with such a heavy wire, so we go 50 amp, we are going to have to enlarge this hole for it to accept it. We have our big grommet to go through our box with our wire. Then we have our 30 amp plug, which we're going to put in our box, and we can change that to a 50 amp at a later date. And over here, we have our box assembly. Everything's going to be installed in the cap of this box, going through to the other side, and then we'll have the remainder of the box basically for our electrical. And it's going to be tight. There's going to be a lot going on in there with a little space to work. But basically, 240 volts, and I'm going to explain this so it's nice and easy to understand, is 4 wires. You have to have 3 if you're properly grounded, but basically 4 wires. So what you have a red wire and a black wire. Both of them are lines. Each one of these, the red and the black, will carry 120 volts each. Then you have your common, which is your white. And in a generator, common is bonded to ground inside the generator, which if it's going to be a home backup generator only, it needs to be disconnected in the generator because it's also neutral is bonded to ground inside your breaker box. Then you have your ground lead, which is crucial for proper grounding. When you plug your generator in, and if you're properly wired, your generator is ground through your ground rods for your circuit breaker box. So we're going to go ahead and start prepping for assembly of this unit, and we'll be back shortly. This video is probably going to be a little time consuming, so it's probably going to be broke down into possibly 2, maybe 3 parts. We'll take it one step at a time and see where it goes. Okay, now in preparation for this meter build so we can test generators, first thing we want to verify is we have a good meter and it's properly functioning. So what we're going to do, we're going to go ahead and we're just going to connect a 110 volt plug to it to test it. Now it does take some skill to design and build one of these. So if you don't have any electrical knowledge, even a basic knowledge, I would not recommend attempting to build one of these yourself. I would get help from somebody who knows exactly what they're doing when it comes to electrical. Because electrical will shock you. It is very dangerous. So we'll go ahead, connect our 110 volt plug to our meter. Make sure we have a good meter. And then we'll go ahead and plug that in. We got the 2 screws and then goes in there. And this is just basically nothing more than just a 110 plug. So we'll have our common and we'll have our hot. We'll plug it in, verify that the meter is properly functioning, and then we'll determine what we want to use to do a light duty load test on it, what I have available, as opposed to having to bring something big out so we can confirm amps. So we just went live, and you can see here multicolor. Right now you can see the LED set to channel 1. It's showing 118 volts at 60 hertz. It's not showing us any amps, PF, no kilowatt hour, and no watts. Now when we change channels and we go to channel 2, which you see now we have the green LED, we're on channel 2, which will be this one here. You can see our voltage and our hertz did not change. We are still running off the same line. And that's why we're adding the switch in, so we can cycle back and forth from line 1 and line 2, which are the two lines that equal our 240 volts, both being 120 each. So I'm going to find me a device that I can use so we can go ahead and do a watt and an amp test and a PF test on this meter, and we can make sure that it is fully functional. That way you can see exactly what we're trying to do with this specific meter. And as we go, it'll become more and more explanatory. And then when you see the live test on a generator, it'll become a lot more understandable at that time. So I'm going to prep and get something ready to run some sort of test on something to determine amps, and we will be right back. Okay, we're back. Okay, so what we're going to do, we are going to test our amps with this electric angle grinder. What we did, we took a small extension cord and we run the common through the internal circuit transformer, and we run the line through the external circuit transformer. And we'll go ahead, we'll get this thing plugged in. Now, as you can see, now we'll zoom in strictly on the meter. Now, as you can see, we have 0 watts, 0 kilowatt hours, 118 volts, 60 hertz, no amps, no PF. Now let's go ahead and fire this grinder up. Now you can see we're about 140 amps, running 1.18 or 130 watts, 1.18 amps. And we're running a power factor of 0.97. It takes time to build up for the kilowatt hours to clock. So now let's go to channel 2. Now we're on channel 2, and let's see what our reading is. And we're getting a good reading on channel 2 as well. So we'll take that, consider it good, but we are running at 126 watts, 1.10 amps on that side. And we go to channel 1, and we're reading exactly the same, as you can see. And still 0.97 at the power factor. We're still at 60 hertz. Now this would have to run for a while to start registering any kilowatt hours. The kilowatt hours that it registers is basically the same kilowatt hours on your meter on your house. So it takes time for it to calculate and add up. But we've got everything functioning properly as it should. So the meter is good. This will conclude part 1. We will include the links for parts 2 and parts 3 in the comments below, along with the links to all the parts that we ordered to build this, including the adapters and links for the components for the changes to go to the 50 amp off the original build. Please like and subscribe if you enjoy our content. Have a great day. Okay, so between the video clips, what I did on this project, I made me a cardboard template where I cut all my pieces, determined exactly where everything was going to go. I got my hole for the plug, hole for the meter, and my hole for the switch. That way I could spec it out on my piece and go ahead and cut it. Try to avoid errors in cutting the box, because once the box is cut, it's cut. There's no going back. So you don't want to make mistakes. So this is basically the jig that I had made. I cut the circles out with hole saws. I used a small grinder with a 3-inch cutoff wheel to cut the square. And just basically for the switch, I just drilled a hole in the middle and then lined up the mounting plates and went ahead and drilled the holes for the mounting plate. So what I'm going to do from here, I did make a change in plan. I was originally going to go with the 30 amps plug, but after I thought about it, enlarging a hole is a lot harder than drilling it the first time because I use a hole saw. So I decided to just upgrade and go to the 50 amp plug in the box right away. I do have a 30-50 amp adapter that I can use for the smaller one. And I also assembled the box and cut the hole for the inlet grommet that's going to go in for our power cable. And that will go ahead and allow us to have a good secure power cable.